First topic is transformation of coordinates. So here we can get two types of transformation of coordinates. Number one is called translation and number two is called rotation. So let's start with translation. Translation is, suppose we have old coordinate system, two dimension coordinate system O 0, 0. This is our origin. This is positive x-axis. This is positive y-axis. Now suppose we are translating that origin 0, 0 to some another point, say h, k, and claiming this is our new origin, and considering another line parallel to our previous x-axis and naming it as new x-axis x dashed, similarly y dashed. So this is our new coordinate system, this is our old coordinate system. So any point in that old coordinate system will be denoted by x, y, and a new point, any point in that new coordinate system will be denoted as x dashed, y dashed. So what is the relation between this old and new? This is our actual rule. This is x equals x dashed plus h and y equals y dashed plus k. This is the formula of translation of coordinates, where what is x, y, x dashed and all? X, y is the old coordinate system, x dashed, y dashed is the new coordinate system, and h, k is our new origin. Okay, you have to memorize this formula. We will solve problems by using this. So first example is, let's try to solve this one from the exercise. Question number 1. Here it is stating that the origin is shifted to the point 2, -3 without changing the directions of the axis. Find the coordinates of the point referred to the new set of axes if its coordinates with respect to the old set of axes be 3, 1. So what it is saying, that the origin is shifted to the point 2, -3. Now what is our origin? New origin is h, k. So we can write that h, k will be our 2, -3. Next, it is stating that find the coordinates of the point referred to the new set of axes if its coordinate with respect to the old set of axes is 3, 1. That means old coordinate is given, which is 3, 1. We have to find out the new coordinate. Old coordinate means x, y. So x, y is our 3, 1. We have to find x dashed, y dashed. Okay. Now using this relation, x equals to x dash plus h and y equals to y dashed plus k. Putting the values, x is 3 and h is 2. So from here we are getting x dashed equals 3 minus 2, 1. Similarly, y is 1 and y dashed is y dashed. We have to find it, and k is minus 3. So from here y dashed is 1 plus 3 equals to 4. That is our new coordinate is 1, 4. Okay, this is the required answer. Similarly, let's solve question number 2. It states that find the transformed equation. Find the transformed equation of the straight line x by a plus y by b equals to 2 when the origin is shifted to the point a, b. Okay, so we have to find the transformed equation of the straight line, this, because this is the equation using the old coordinate system. Okay, and the origin is shifted to the point a, b. That means this is our new origin. Actually this is our h, k according to our formula. So h, k is given, x, y is given. We have to find out x dashed and y dashed. Okay, so let's start with, let us taking h, k equals to a, b. So here answer, here h comma k equals to a comma b. So we have x equals to x dashed plus h, that is a, and y equals to y dashed plus k, that is b. Now we have the equation as x by a plus y by b equals to 2. Now put the values. X, it means x dashed plus a by a, plus y means y dashed plus b by b equals to 2. Now simplify it a little bit. X dashed by a plus a by a, y dashed by b plus b by b equals to 2. A by a means 1, b by b means 1, that is 1 plus 1, 2. So x dashed by a plus y dashed by b, 2 minus 2 equals to 0. That is, this is our new transformed equation. Check, there is no x and y. There is all are x dashed and y dashed. So this is our new transformed equation. Okay. So this is how we solve equations or problems when it is given about the shifting of origin. That is the first part, translation. Now we are moving to the second part, which is called rotation. So here what happens? Rotation of axis. We have the normal coordinate system O, which is 0, 0. Then this is x, this is y. Suppose the coordinate system is angled like this. It's for some angle theta. So this is our new x dashed, this is our new y dashed. Then what will be the relation between old system xy and new system x dashed y dashed? So to find their relation, we have a table. We have to memorize this table. This is xy, writing it here xy, and here x dashed, y dashed. This is cos theta minus sin theta, cos theta. Okay. So x value will be x dashed cos theta minus y dashed sin theta. X equals to x dashed cos theta minus y dashed sin theta. And y equals to x dashed sin theta plus y dashed cos theta. Okay. Similarly, we can express x dashed y dashed also using the value of x. So the value of x dashed will be x cos theta plus y sin theta. So we are writing this formula also, x dashed equals to x cos theta plus y sin theta. Similarly, y dashed will be x minus x sin theta plus y cos theta. Okay, so these are the two rules, that is the relation between the old and new coordinate system. You don't have to memorize these two rules, you only memorize this table, so you can compute the rules from there. You just have to write down xy, the old system, on the left hand side, and on the top the new system x dashed y dashed, and write down cos theta sin theta here, then apply their derivatives on the right hand side. This is another rule to memorize it. Cos theta's derivative minus sin theta's derivative cos theta. So we have to just memorize this table, then we can construct these two rules. These are the two formulas for rotation of axis. Okay. Now let's solve few examples using this formula. So the question, example 3. The axes are rotated through an angle 30 degree with same origin. Then find the new coordinates of the point whose old coordinates were 2, 4. Okay. It is given that the axis is rotated through an angle 30 degree. That means here theta is our 30 degree. Okay. And we have to find the new coordinates where it is given the old coordinates are 2, 4. So here answer, here theta equals to 30 degree, x comma y is our old coordinate which is 2, 4. Then we have to find out x dashed comma y dashed. Okay. So we will apply the rule, that is x dashed equals to x cos theta plus y sin theta and y dashed equals to minus x sin theta plus y cos theta. So by using that rule, what are we getting? If you put it here, x dashed equals to minus x means 2 into cos 30 degree plus y, that is 4, to sin 30 degree. And y dashed equals to minus x, that is 2 sin 30 degree plus y, that is 4 cos 30 degree. So put the values. This will be minus 2 into cos 30 takes the value root 3 by 2 plus 4 into sin 30, it takes the value half. So it will become minus root 3 plus 2. This is our x dashed. Similarly, compute y dashed. Minus 2 into sin 30 degree half plus 4 into cos 30 degree, that is root 3 by 2. So it will become minus 1 plus 2 root 3. So our new coordinate is minus 3 plus root 2 comma minus 1 plus 2 root 3. Okay. This is our new coordinates of the point 2, 4. So this is how we solve the problems using rotation of axis. Next example, example 4. Transform the equations x square minus y square equals to a square to axis inclined at 45 degree to the original axis. Transform the equations x square minus y square equals to a square to axis inclined at 45 degree to the original axis. So here theta is 45 degree. Right? This is our equation in the old coordinate system, that is x comma y. We have to find it in the new coordinate system, which is x dashed comma y dashed. So apply the formula. X equals to x dashed cos theta plus minus y dashed sin theta, and y equals to x dashed sin theta plus y dashed cos theta. So putting the value of theta 45 degree, that is x dashed cos 45, which is 1 by root 2. So it will become x dashed into 1 by root 2 minus y dashed into sin 45 degree, that is 1 by root 2, equals x dashed sin 45 1 by root 2 plus y dashed sin 45 cos 45, that is 1 by root 2. So this is the value of x and this is the value of y. So let's put that two values in our old system of equation, that is x square minus y square equals to a square. So we have x square minus y square equals to a square. That is x dashed by root 2 minus y dashed by root 2 its whole square minus x dashed by root 2 plus y dashed by root 2 its whole square equals to a square. Now simplify it, apply a plus b whole square a minus b whole square formula. Okay, these two terms got cancelled out, and from these two terms we are getting 4x dashed y dashed by root 2 into root 2, that is root 2 square, which is 2, minus equals to a square, that is a square minus minus 2x dashed y dashed equals to a square. So check, here is only x dashed and y dashed, that is this is our new equation when the axis has been rotated by an angle 45 degree. Okay, this is how we find the new equation by using the rotation of axis. Let's solve next question. Example 5. Reduce the equations x minus y plus 3 equals to 0 and 2x minus y plus 1 equals to 0 to the form ax dashed plus by dashed equals to 0 by proper choice of origin. By proper choice of origin. Now check here, the old equations are given, x minus y plus 3 equals to 0 and 2x minus y plus 1 equals to 0. You have to find the new form. This will be of the form like this, that is some constant into new coordinate x dashed plus some constant b into new coordinate y dashed equals to 0 by proper choice of origin. That means you have to find out the origin also, and you have to reduce these old equations into the new equation of the form like this. Okay, so we don't know what will be our new origin, so let's take new origin as h comma k according to our theory. So let the new origin is h comma k. Then we have the rule x equals to x dash plus h and y equals to y dash plus k. Now starting with the first equation given, x minus y plus 3 equals to 0, putting the values there. Opening the brackets, keeping x dash y dash together. Okay, keeping this one as equation number 1. Now starting with the second equation given, that was 2x minus y plus 1 equals to 0. Doing the same procedure here. Opening the bracket, keeping x dashed and y dashed together. This is number 2. So this is our new equation and this is also the new equation. Now check the question. It is saying the new equation should be of the form ax dashed plus b y dashed equals to 0. Right? This should be the form of the new equation. That means check, there is no constant term. Only some coefficient of x dashed and some coefficient of y dashed. So we got these two as our new equation. That means these constant terms of two new equations must be 0 according to the rule given in the question. So we have h minus k plus 3 equals to 0 and 2h minus k plus 1 equals to 0. Now two linear equations in h and k, we can easily solve it. By solving, we will get h equals to 2 and k equals to 5. That means our new origin is 2 comma 5. Okay. So this is how we find the new origin if it is not given in the question. Just take it is as h comma k, then we have the rule x equals to x dash plus h and y equal to y dash plus k. Just put it in the old equation or new equation, whatever is given in the question, then you will get the previous questions. And according to the condition, that is the new equation should be look like this. We are getting that the constant term must be 0. So by putting them 0, we are getting the value of h comma k. Okay. Next. Next example. Example 6, I guess. Find the angle. Find the angle through which the axis must be turned, through which the axis must be turned so that the equation lx minus my plus n equals to 0 may be reduced to the form ay dashed plus b equals to 0. To the form ay dashed plus b equals to 0. So find the angle through which the axis must be turned so that this equation, this is our old equation, may be reduced to the form new equation. Okay. So we have to find the angle. That means theta is unknown here. This is our old equation xy. We have to find theta and we have to turn that new equation of the form look like this. So let's take that the angle will be theta. Then we will apply the rotation formula. Let the axis must be turned through the angle theta. Then we have the rule x equals to x dash cos theta minus y dash sin theta and y equals to x dash sin theta plus y dash cos theta. Okay. Now we have the new old equation given in the question, that is lx minus my plus n equals to 0. Put the values over here. Okay. Opening the brackets and keeping all that x dash y dash together. So if you take that x dash and y dash x dash term together, we are getting L cos theta minus M sin theta. And then if you take common minus y dashed, it will look like, or plus you can take it, minus L sin theta minus M cos theta plus n equals to 0. This is our new equation. Now check, according to the question, the new equation should look like a y dashed plus b equals to 0. This should be the form of the new equation. That means check, in the new equation there is no term using x dashed. That means the coefficient of x dashed must be 0 in the new equation. there will be only y dash term and some constant term. So what is the x dash coefficient here in the new equation? This is this thing, L cos theta minus M sin theta. So according to the rule of the question, this part should be equals to 0. So L cos theta minus M sin theta should be equals to 0. Let's find out the value of theta from here. L cos theta equals to M sin theta, and then L by M, this will be equal to sin theta by cos theta, that means tan theta. So theta equals tan inverse L by M. This is the required angle through which we have to turn the axis, so that the old equation Lx minus My plus N will take the form Ay dash plus B equals to 0. Okay. So if the angle is not given in the question, that's how we find out the angle. Okay. Now there is another shortcut rule of finding angle, which is, suppose we have one equation ax square plus 2hxy plus by square equals to 0. Now we have to turn the axis in an angle theta to remove the xy term, by the angle theta, where tan 2 theta equals to 2h by a minus b. Okay, so this is the rule. That is, we have to rotate the axis through an angle theta to remove the xy term in the equation if tan 2 theta equals to 2h by a minus b. This is a shortcut rule of finding the angle theta. So let's apply this to find answer of another question. So write down next example 7. Through what angle must the axis be turned to remove the term xy from the equation x square plus 2 root 3 xy minus y square equals to 4. So it is asking, through what angle must the axis be turned to remove the xy term from the equation, this one. Okay, so we will apply the previous theory, that is, for the equation ax square plus 2hxy plus by square equals to 0, the angle should be tan 2 theta equals to 2h by a minus b, right? So at first, if you compare, a will be 1, a means the coefficient of x square, then h will be root 3, that means half of the coefficient of xy terms, and then b will be minus 1, the coefficient of y square. So put the values, 2 into h is root 3 by a is 1 and b is minus 1. So 2 root 3 by 1 minus 1, that is plus 1. So 1 plus 1, 2. Tan 2 theta equals to root 3. So find out the value of theta from here. Root 3 means tan pi by 3. That is 2 theta equals to pi by 3. So theta equals pi by 6. So this is how we find the angle. This is how we find the angle when we have to remove xy term from a particular equation. So then we apply the formula tan 2 theta equals to 2h by a minus b.